Welcome to CCSD Earth Science. Today we're going to be talking about continental drift. And continental drift is the idea that the continents and the plates that they're attached to are all moving across the surface of the Earth. And the idea was introduced by a German scientist, Alfred Wegener, in 1915. And he proposed that at one time the continents were all connected into a supercontinent called Pangaea. And he believed that this occurred, and we today believe this occurred about 300 million years ago. Now there was some evidence that led him to this theory. One of them is the continental shapes. Okay, he was looking at a world map and he noticed especially South America and Africa, how they kind of look like they fit together if you were to cut them out. And he actually went through and cut out the map of the world and moved the pieces around or the continents around like they were puzzle pieces. And they didn't fit perfectly, but some of them definitely did. And so that's where that was like his first thought that this might have happened. Then throughout time he started getting some evidence, such as matching fossils. There are fossils that are found on different continents for organisms that could not have swam across the entire ocean. Okay, so like South America and Africa, there are fossils of a fern called the Glossopteris fern that are found on the eastern coast of South America and the western coast of Africa, just in these areas. So if you were to put the two continents together, they could very easily match up. Now you think about a fern, it's a plant. There's no way that that could have made it across the entire ocean. So, along with Wegener's theory, is that they were connected at one time, and during that time, those organisms could easily transfer back and forth. Then they became extinct, they fossilized, and the plates and the continents have drifted apart, and now we have these fossils on two very different continents. Another fossil that he used was the Mesosaurus, which kind of looked like an alligator. And again, that was another one that was found on different continents, but they're so far apart, there's no way that they could have transferred back and forth across the ocean. The continents had to have been connected at one time. Now, over time, more evidence has come about. Mountain ranges and rock types. Again, when you put all of the continents together, there are matching mountain belts that connect. Okay, one example would be the Appalachian Mountains. That's a C there. The Appalachian Mountains in the eastern part of the United States. And when you match them up or connect them with Europe and the northern part of Europe, Greenland, Norway, and the United Kingdom all have similar rock types and mountains that match up into this one continuous mountain belt. But until you put them together, you wouldn't realize that they were all connected at one point. Okay? And again, so similar rock outcrops are also exist along different continents. Some other evidence are the ancient climates. Okay, we know that one of the pieces of evidence we have that the plates were moving is glacial evidence, which are scratches or striations, which are found on land masses that are near the equator. Okay, so they're finding scratches from glaciers at places near the equator. Okay, the equator we know is warm. So what that's telling us is that these places that are near the equator now used to be at a higher latitude, a place where it was colder. And that's when the glaciers existed, scratched the bedrock, and then over time those continents have moved closer to the equator, and we can see those scratches there now. Another ancient climate piece of evidence are coal deposits. Okay, coal deposits we find at high latitudes. We have coal deposits in America. We've got like Pennsylvania, Virginia, West Virginia, places like that where we find coal, but coal forms in warm climates near the equator. Pennsylvania is definitely not near the equator, but what that's telling us is that it used to be there. Okay, there used to be a time when we were closer to the equator, it was warmer and allowed for these forests to form that eventually became the coal deposits that we have today. So these are two pieces of evidence that relate to climate that tell us that these places have moved. They used to be closer to the equator or farther from the equator than they are today. It's not that the climate has changed that drastically at the current latitude that those places are at. Now, unfortunately for Wegener, he could not explain why the plates were moving. He had great evidence to show that they probably were connected at one point, but he couldn't explain why. And that was a problem. Okay? A lot of people didn't buy into his theory because of that. They just didn't think that huge, massive continents could possibly be moving across the surface of the Earth. But later on, luckily, they were able to solve this mystery. In the 1950s, there were ships that were surveying the bottom of the ocean floor, and they noticed that there was a pattern in the rock, in the magnetic polarity of the rock. Okay? They were finding it was a symmetrical pattern. Okay? So you'd have places where it would show north, as north is today, but then other places, and they would be symmetrical along the bottom of the ocean floor, that actually showed that the north and south magnetic pole had reversed over time. Throughout Earth's history, the north and south magnetic poles change. Okay, and this was a huge piece of evidence because there was no other way to explain how you're getting this change other than the continents are moving apart in certain places. And where they're moving apart, you get this brand new rock that comes up. Okay, the lava reaches the surface, and at that point when it's still liquid, the iron that's in it aligns itself with where north is, and then solidifies and becomes the solid rock that we see. Well, at the times when the magnetic poles were reversed and that new rock was forming, it recorded where north and south were. And as you can see, throughout history, it's flip-flopped. Okay, so these two are the same age because they're right next to each other. And then they get pushed further away from the center part of the ocean floor. These two used to be in the middle, and these two used to be in the middle. So as you go towards the continents, if you're in the middle of the ocean and you go towards the continents, the middle is your younger rock, and as you get closer to the continents, that's your older rock. Okay? And they were able to figure this out by just looking at the magnetic polarity of the rock. And it wasn't something that they were necessarily looking for, it's just something that they stumbled upon. And this evidence was huge. This showed the plates were actually moving, and it helped to support Wegener and his theory. So this idea that the north and south pole flip-flop is called paleomagnetism. Okay, so like I said, the rock records the alternating patterns of Earth's magnetic poles over time. It's changing, and it's detected in the ocean floor, but it's also in cooled layers of volcanic lava. So you've got, again, that lava that's brand new rock, and it's just starting to solidify, and as it does, it orients itself with north, just like the needle of a compass, and then it solidifies. Well, then you have another volcanic eruption, because volcanoes erupt several times throughout their life, and at different times the north and south pole have flip-flopped, and we can see that in those layers of volcanic rock. The pole reversals occur about every 200 to 300,000 years. Okay? And it's estimated that a complete reversal may take 1 to 2,000 years. So it's not something that you would wake up one day and north and south have flipped. It's a slow process. And even when it does eventually occur, because it will happen again, they don't think that anything catastrophic will happen because it has happened several times throughout Earth's history, and there's nothing in the record of Earth that we've had mass extinctions or anything like that. So really our lives shouldn't be too interrupted by an event like this. Other than the fact that our compasses will be flip-flopped. Your north will be backwards on your compass at that point. You'll have to make new compasses, so I guess that'd be good for the compass industry. But for us humans, it really won't make too much of a difference to our everyday lives, and as you can see, it's not something that's going to happen right away anyway, so it's probably not anything that we'll see. But this paleomagnetism was a big idea to come about that helped promote Wegener's theory of continental drift.